In some networks, we might not always have physical control of every single cable run. Maybe some of our cables go through a shared physical infrastructure, or maybe there's an accessible wiring closet, or in the basement of a building there might be a patch panel. In some cases, an attacker can gain access to that cabling, and if they're able to tap into that cabling, they're able to potentially eavesdrop in and even tamper with the traffic going between, let's say, switch A and switch B in this example. The attacker, using a network tap, got a copy of those frames. The good news is we can use MACsec, which is the topic of this video, to provide layer 2 encryption between one switch and another switch, or between a PC and a switch. MACsec, by the way, that is an IEEE standard. It's IEEE 802.1AE. And if we have MACsec enabled between switch A and switch B in this example, the attacker, even though they're tapping into the network, any traffic that they capture, it's going to be all scrambled up. They're not going to be able to read it. And here on screen, you can see a couple of fields that get added to an Ethernet frame by MACsec. And MACsec is going to give us three primary features. Number one, confidentiality. Here we're talking about encryption. We can scramble up the data in a payload, so if it is intercepted, it's not going to be readable by an attacker. Another feature that MACsec gives us is integrity, meaning that we can detect any manipulation of the data. If an attacker were to tap in and corrupt the data, or change the data in some way, we're going to be able to determine that with MACsec. And the third big feature is replay protection. And the idea here is an attacker might capture some traffic, and even though it's encrypted, even though it's scrambled up, they're not going to be able to take those captured frames, which were valid at the time they were captured. They're not going to be able to take those captured frames and then play them back later. And the secure connection between one switch and another switch, or even between an endpoint like a PC and a switch, if that PC is running appropriate software, that secure connection is made possible by MKA. That's MACsec Key Agreement, which leverages 802.1x to exchange keys between peers, whether those peers be a PC and a switch, or one switch and another switch, allowing us to have switch-by-switch encryption across a layer 2 network. And that's an important concept to visualize. As we see in that top diagram on screen, MACsec is going to do encryption link by link between one switch and another switch. It doesn't do it end-to-end. That's as compared to IPsec, which does give us end-to-end encryption. So in the case of IPsec, if routers R1 and R5 are configured for IPsec, the routers in the middle, they don't need to be. But in the case of MACsec, all 5 switches in our example, they would need to be configured for MACsec because at each switch hop, traffic is going to be decrypted, so each switch can make an appropriate forwarding decision, and then it's going to be re-encrypted and sent to the next switch hop. And that is a look at the MACsec standard. It's an IEEE standard that gives us layer 2 security between our switches on a hop-by-hop basis, and even between an endpoint and a switch.